And the ad is done, which means for life we're starting up. Let me see. Yep. Telegram. Let's shoot this one. Almost. Come on. This time it should go in. Finally. Anyway. Anyway. Let me do this one. It's so easy. If this function is heavy, it's not easy. Zig one. Zig is like my favorite plushie because it's pretty much a brick and it's so elastic. Well, one of my favorites. Okay, this one's heavy, I'm not gonna do that. It's not a basketball stream. We actually have some work to do. Which is, first of all, comp times and blocks. Not operator overloading, sorry. First we need to get comp times and blocks. Let me check git status. By the way, I should theoretically compile Orco, but there is nothing really. So there's nothing, not much changes, so I'm gonna leave it yet. Before we, at least before we get comp times and blocks, which is I can do comp time message. Can I do? I don't remember if I can do like colon in comp times. No, I can try. So this should print hello world, obviously. Obviously. Oh, not yet implemented C-string value. Let me go here. I mean, C-string value is just a vector of U8s, no? Value new so C-string is what? Vector and metadata. So we're just gonna do value. Can't I just do this really? Like literally. Or actually no. I can use Rust C-string. Or I can just do a pointer. Not a pattern, what? Okay, sure. Oh wait, it's double dot. Hold on. Okay, so value new. The value. I mean, we can leave that. I guess. I mean, it owns a string. It owns a C string. Same time, C string is really a pointer. I don't know. Like actually, I guess I'll just do a vector. Huh? Um, okay, so this should work. Well, actually, it still should panic as unsupported in one place. Unsupported constant value type. Okay, so we have this here. So I'm gonna add type cstring. Wait, pointer to a type. Oh wait. Okay, we can't actually do that. Well, maybe we can, but that's out of the scope for today. Um, Restore Oracle status. So then let's bring back hello world, and let's return value. Value. Oh, a new post was created. Garbage collector is getting posts. So this will be I32 and it will be 42. So yeah, types actually work for constants. Let's just check out the post. So here there are no comments, but if we go, okay, if we actually go to notifications, let's see. Yes, I did it, HJKL. How to code? Ah. Post. I mean, I don't know. It is not counterintuitive. It is unintuitive. Yeah, this game doesn't have controls. I mean, it does have controls. It doesn't have um any way to tell what the controls are, which is the point. Maybe we should play some games. Hi, Nigel. Okay, so if we echo this, yeah, works. We can remove that, and now we move this here. What is a chore? A specific piece of work related to be done as a duty or for a specific fee. Is this the same thing? Can you hear the car? It's so loud. Okay, yes, yeah. So this is what we're doing first, but it's pretty simple. So if we go to block rs, oh yeah. So a routine. That's what I normally call it. Well, it's not really a routine, I guess. Anyway. So block parser, block itself. Let's add comp times into a block. Or actually symbols. No, let's leave it as comp times. Okay, so this is just a symbol. Oh my god, it has to have a path. Hmm. I mean, we can try implementing that. Symbols. Well, it's not symbols, it's comp times. Maybe we'll cancel this one actually, because I don't know. I'm not sure about it. Get type doesn't really matter. Infer types. Okay, so on this stage we evaluate all of those, I guess. Uh, uh, ensure evaluated. So we'll go for each symbol in symbols. Well, those are local to the block. Sorry. Ensure evaluated. Oh, this takes RW lock, which is annoying. Can I wrap it in RW lock temporarily? Oh no. I mean, I can wrap it in RW. Okay, so this is just experimenting. Okay, so here, self symbols, borrow that. Wait, not symbols, comp times. Okay. So ensure evaluated doesn't return anything, right? Right. We also like need to register them technically. Finish and check types. Well, we already reported some stuff in here. Okay, so I mean, I mean, is this actually? Like, I'm thinking what else I need to do, except like actually adding them. And I feel like that's really it. Comp times. So have comp times and expressions. Then if if parser match keyword comp time, then we just do comp times push. How do we actually? Okay, so if we go to modRes, I think in here. So that's what we do. Or actually parse. We can actually just parse symbol in here. If wait, no. If some symbol equals parse symbol, parser, then syntax expect, so we're fine. And just add symbol and continue. Let's try to compile it. It won't. Okay, so first of all, this is not clonable. Oh, come on. Come on. Comment this out. Maybe then it will turn the clone into proper impl clone. Oh, okay, it won't. She said, why can't it like generate clone? Which is self comp times iter map symbol try read unwrap clone wrap this in rwlog new qualifies rwlog collect that comp times done, fill more fields, self expressions clone, not clear, clone, self tail expression clone, self transparent. It doesn't even need cloning because it's copy, self span clone, self metadata clone. Okay, now it should compile, and I mean it won't run, but it doesn't compile still, which is annoying. Oh wait, yeah, I need to also wrap this in rwlog. Then we have, well, I could just intuit, but I mean, I don't care. Then we could just compile it. Okay, still no. Apparently this was an error. Create an empty block. Actually, we could default it. Actually, what we could do, since it probably all has all fields as public, we could do this. So this is span, and then hold in here. Oh no, please format. What's wrong? Oh yeah, comma. Comma has to not be here explicitly. Oh, and a semicolon. And a semicolon. Why don't they have a semicolon? Like by default. Symbol reference doesn't matter yet. Where's parser? Okay, so here, do I actually like... Okay, so this parse symbol. It's like actually weird. Just do that and it should work now. Okay, so now if we go to type inference, no, a different type inference, and this reminded me of tests. Actually, go to scopes. So scope Can I turn this into a struct? I guess I can't. Symbol, actually, symbol reference. Actually, I can just go to block, and here I can actually just so here I ensure evaluated. Then I do not self type inference current scope mutable insert symbol name. Huh? Wait, I need to try read. Name clone. Then so this is what? This is scope. So we need a symbol. Oh, we need symbol reference symbol. Yeah, and it takes an internal pointer of RW lock. We need to wrap it in internal pointer. Internal pointer. I'm not energetic. Where is all my energy? Symbol. We need to make this pinnable. Which means wrap this in pin box. Which means this type now is even more complicated. Pin box pin. Okay, so this is okay. We are missing this, I think. Okay, now this crazy type. Where is new? Too many? Okay. And now option of symbol reference doesn't really matter. Now internal pointer new symbol as ref. Okay. And then go to parser block and wrap those symbols in box pin also. Pin boxer W lock. Wow, what a type. And this is all in a vector. Unmatched angle bracket. How did I mess it up? Okay, something. Okay, still unmatched, I guess. Box. So RW lock of symbol. Then this is a box. This is for a pin. Okay, I removed a little too many. I guess. Actually, like judge by color. Okay, and it compiles and oh wow, this was easy. I mean, I guess that's how you implement them, but still, that's not all. X equals 21. X times 2. This might not work. I'm not sure if it will. Not yet implemented. What? Symbol. Oh, it's not implemented. Okay, so can we get type inference in here? Okay, so this is actually gonna be problematic. I mean, I can hold an option of type inference. Or I could pass in a scope, or I could pass in something else. But I mean, symbol metadata, which is used to resolve stuff. Symbol metadata, which is used to resolve stuff, takes a type inference. So I guess I'm gonna pass it into the interpreter. I'm not sure about it, honestly. I mean, hold on. So first of all, actually, add git commit shm. Okay, so first we need to go to readme, mark this as done, add commit times blocks push. Then we are gonna add type inference in here. So this is gonna be option. Well, this needs errors. This is like, wow. This is gonna give us errors. So type inference. It's not really type inference anymore. We need to rename it to something. It is the central struct of type inference checking and stuff. Name metadata. Okay, so here if let some inference equals type inference. Okay, so we need to, if there is no type inference, we need to panic. Well, not panic, we need to report an error, but we don't have type inference, so how are we gonna report it? And yeah, like, how are we gonna get a value? Erroneous value? It's just panic, I guess. Failed to evaluate. Okay, so this turns out to be a big topic. Like, if I open readme, so I mean, yeah, where are we? So this was a big refactor. Comp time type hints. What is that? Yeah, this was actually simple. Then those two got cancelled. This was so this was. I mean, where is it? So this was meant to be simple. It turned out to be a big topic. This was meant to be simple. It turned out to be a big topic. What is happening? Um, yeah, let's panic for now. As a proof of concept. Not type inference, then I do metadata resolve. Oh, I don't even know how to resolve it. Wait, hold on. Yeah, how? Why? Yeah, we don't need to resolve it. Hi, it should be inferred. Hold on, what? Okay, hold on. We don't need type inference in here, do we? It should be like before. It should be compiled. It should be checked already. So we should be able to just do name dot. Sorry for unintended ASMR. Symbol reference. So we need to map. Not map. Okay, what's wrong with me today? So this is not name. This is a symbol reference. I thought it was meant to be a symbol reference actually. Okay, so unresolved and scope access. Let's do underscore. Unique. Need sim ref type in interpreted IR. Symbol reference. Reference type unresolved symbol in interpreted IR. Okay, let's do this. Symbol reference expected struct spent inner. We're matching inner. Do we really need to borrow it? I don't know. Okay, so the symbol. The simplest is the symbol, I guess, which is an internal pointer to an RW lock of a symbol. So here, we had like symbol. If we take a look at infer types, I think. Okay, hold on. If we go to crane lift, backend, symbol. What? Symbol reference expression. Okay. Symbol reference to a symbol. Symbol. Non-evaluated symbols. Okay, so symbol evaluated. We'll just use symbol evaluated as a constant value. What am I doing? What am I doing in here? Symbol try read unwrap evaluated unwrap clone. And in here, if it is a function, then it's gonna break apart, no? Oh, value is not clonable. Never mind. Okay, so is this possible? I mean, this should be possible, but how? How? So first of all, should it really be cloned? I mean, makes sense to be cloned. Well, at the same time, symbol reference, there might be an assignment to it. So finishing interpreter will be a lot of work. I can see already. So those were meant to be owned values. What about the reference operator, for example? Huh. But yeah, theoretically this should be just cloned or something. But we can't clone values, which is a problem. What do we have in Oracle, Cargo, Toml? Don't we have a trait for this? Didn't clone. There is didn't clone, dynamic clone. Which is used for the thing. Uh, din any clone rust. Time to make values clonable. Why am I running out of my water? It has been like what, an hour? Less than an hour, much less than an hour. I mean, I can't use din clone because it's any. Unless I like make a special trait, which can be implemented for anything, for dynamic any. Uh, any clone. I saw a trait for this. Clone any. Clone dynamic types. What is this report? A big report create button. I don't think I saw it before. Clone dynamic type, clone dynamic. So this is trait where self is clone dynamic. Dynamic clone works better. But actually, there was a type. Box clone any. Din clone, clone din. Like actually, what is that? Okay, I guess we'll have to define a trait. Trait value, which requires the trait to implement any plus din clone. The trait won't have any methods. What is it? Value trait. Oh, also sentencing. Value trait. Can actually move into this here. What? What do you mean debug? Like, how did box of dynamic any implement debug? Implement missing members. Self 0 sstd any fmt f. Is it gonna work? Like, how did any implement debug? How is value debuggable even? We really need debugging here. T value trait not satisfied. Okay, so T was The point is that t is value trait and also static, so owned, I guess. Impl value trait for t. Impl t send and sync. And clone and static. Yeah, actually I should probably move clone first. Then we can do self zero sstd any. Can I do that? No. Any is a trait, right? Use std any. Fine. Oops. Can now remove that. Okay, can I do like box s dynamic any? S box or dynamic any? Like, is it something that makes sense? Temporary value. Okay, can I do like let any? I don't know. Let value equals self zero as ref. So this is gonna be a of dynamic any. I mean, it's contract. There's a contract. It has to work, right? You have a contract for it to work. Trait upcasting coercion is experimental. What? The feature gate exists at least. Do you have any feature gates? Libres. We don't actually. So this should somehow compile on stable Rust. Corresponding MCP, what is that? I mean, what's the problem with it? Okay, let's add a feature gate. How am I gonna compile this? How am I gonna self-host? That's like my question. Oh, I can get. I can actually get clone to work. Or can I? Okay, where is value? Put this here. Value trait, and this probably should go in here. And then so value should be clonable. I've clone. Why do I have type ID? I have type ID, but I don't have downcast mute. What? Why do I have type ID then? because it is for a ref. I guess. So this is well for borrowed self. So let's try. It's the same thing. Value. Okay, now borrowed dynamic any. Borrowed mute dynamic any self 0 as mute. Okay, compile sh simple. You can clone whatever. Can't move out of the reference. Log guard as ref, obviously. What is that? Obstacle debug is not implemented for value. What? Where? Impl debug, which we're gonna qualify later. You know, we're not. What? Hey, hotkeys. std fmt debug. Implement missing members. F dot struct debug struct name value dot field is, or actually so we have debug tuple. I mean, I can actually just do right or something. If okay, type ID. Oh, and into obviously the third and the last one. Oh, how am I gonna? So I need the box of dynamic any. Value. It's just gonna work this way. Oh wow, look, it works. With some crazy manipulations, it works. And let's see the result. Obviously, it works. We can actually look at the. It's here we have. Oh, wait, we don't. Oh, we need to display them. I completely forgot about displaying those things. So this is part of the interpreter, I guess, implemented. So if we take a look at this, we can literally call see the value being 42. Anyway, so let's quickly go to first. Okay, first let's go to block. Here we're gonna add comp times symbol in self comp times, right? Indent all by 4 format symbol I guess symbol does write a semicolon. Oh, we need to try read it first. Impl debug for symbol. Yeah, it does write a semicolon. Okay, so where's the block? Here's the block. And I guess it's actually like fine. Okay, so here we actually do symbol. Let's try read, unwrap. Missing documentation for a trait. Possible values. I don't know. I mean, I'm not sure if cloning is good. Is a good idea. Okay, so if we just, yeah, I mean, yeah, I don't think cloning is a good idea. At the same time, it's just symbol. So we were meant to process its value. It's so hot in here, actually. And the window is opened. My control key is like almost almost erased from the keyboard. I need to clean my laptop inside. I should do it better soon, better sooner than later. So yeah, for value we were meant to like, I mean, cloning is fine in this context, really. But then what if we want the value to be not clonable? Then you can't have this constant. I guess. I mean, maybe. Anyway, I mean, this works. So we have a little bit, a little bit more left to do, which is well, variable. Nope. You can't just capture variables here. So ensure evaluated. Well, evaluate. Okay, so let's try. Let's try doing let x equals 21. What happens? I wonder. Assertion failed LHS complete. What? Make equal. Okay, so this is unexpected. This is like actually unexpected. So in here we equate greater than or equal to what? Where is great? What? Wait, no. It's okay, so it's a binary operation. Oh, and so one of them is not complete. Sort types has to return a completed type. So symbol then for a variable. No, it says complete in here. Which means, okay, so was this left hand side or right hand side? It's left hand side. What? Okay, so just to check, for the constant, we are for sure completing the type. Yes, we are. How? So a symbol, a variable, or is it really a variable? Maybe it's actually unresolved. Then this will return an error. And if it couldn't resolve, it will return an error probably also. Panic. Wait. So complete. Oh wait, error is not complete. Okay, so we need to allow error type in here. Or LHS type. Error type. Error. Just a special exception. And if it's error, that means it's a good sign, I guess. Oh yeah, borrows that. And has started. Okay, symbol X was not declared in the scope for some reason, somehow. Yeah, this happened. Somehow. Somehow it works. Which is great. I mean, actually, like variable. If it will be a variable, then it should be tracked. So we'll leave it to do here because we don't yet have variables in here. Like we don't have variable declarations. Like actually, how does it resolve this thing then? I wonder. I just added them and it works for some reason somehow. So when we're ensure evaluated, that's the question. In the ensure evaluated, it somehow resolves something. It doesn't matter. So here we finish and check types, infer types. Okay, so here we somehow we just run infer types, and there are like actually variables, but somehow it doesn't pick them up. What? We need to debug it. Like how? So imagine it's just a symbol reference. Then we also infer types on unresolved, which means we resolve global symbol, which means we actually checked like the get symbol and all that, but for some reason it doesn't catch the variable. What? This is like actually wrong. Why is it like that? Ensure evaluated type inference may have some scopes. Oh dear, pass is wrong. Well, really, this isn't gonna work. So the pass is wrong, which we can fix, I think. but then still it's gonna pick up stuff. Just like actually sort types. Yeah, I think I'm reverting this. Let me think where it might could have been useful. Lig comp times. Okay, so this how. uh, I mean, is this really a big deal? Oh, wait, I know why it doesn't pick stuff up. Because it's at the start of a block. So yeah, I guess we're reverting. Revert. Uh, set hard. Let's revert this. Push that. Read me. So here, first of all, it's gonna mess up those marks. Yeah, I forgot to mark them actually. um, actually, cancelled. Cause yeah, there are a lot of problems with this. Anyway, this one's a big topic. I shouldn't really add too many features, because simplicity is key. Kiss principle is the best one. Kiss is the way. Okay, so operator overloading and traits. Yeah, we actually like got to it, I think. Yeah, I don't know how to do them. I mean, what is the trait? What trait can hold? Trait. What is the trait? In Rust. Abstract behaviors, etc. So traits can have some stuff, including functions, which is the thing we're focusing on right now, types and consts, right? That's trait referent. Just reference. So we have inner attributes and associated items. Oh, okay. So inner attribute. What is that? Okay, so attributes are, well, not really. A trait describes an abstract interface that types can implement. This interface consists of associated items which come in three varieties: functions, types, and constants. Yeah, as I said, pretty simple. So for constants we can use comp time, like really. So symbols. For functions we can also use comp time, because they're also symbols. And for times we can guess what, also use comp times because they're also symbols. So yeah, basically trait is a collection of symbols. That need to be implemented. Okay, let's get to it. So let's open simple and let's imagine the syntax. Close inactive. So there's tests. Remove the tests. Remove that. Okay, so we could create a trait. Can trait be a sim? Can trait be a symbol? Should trait be a symbol, a comp time object? Like, what is a trait? Trait is as a data type. Let's imagine for now that not. Trait is a collection of stuff. So trait add. Well, not add. Let's do trait print whatever. So it's gonna have a comp time. What? So it's gonna have a comp time function called print, which is basically a function. I don't remember how I how I write functions. Well, actually no, it's function like that. Hold on, so we can't specify the signature here. That's a problem. That's problematic. Like, that's actually problematic. I didn't think of it before. Oh no. Hmm. Okay, it will require a lot of work. I can feel. Today's just not the day. I'm like, I've reverted one commit, one to-do list item, and now I can't implement this because of another language problem. It would be like so beautiful if we could just do this, but no, we can't because function is too abstract. It doesn't have like types in it. I mean, we could do it like so. It's not just a function, but it also implements a trait, function trait. But that's like, I mean, actually, this makes total sense. I think, or like callable. Uh, the point is, each of them, each field is comp time. Okay, let's say has type, comp time x, which is a type. I don't think we have types yet, actually. Yeah, we don't have types yet. Any different example? So let's say sized. Like, yes, let's say sized actually. Let's say size, which is a use size. We don't have use size, but we can do use32. Okay. Okay, so this time it actually makes sense. Do we actually not have usize? I think we don't have usize. We really need it. I mean, we can do pointer. We can actually do pointer, but no. Nope. So comp time usize, comp time size usually do. Imagine that. For now, let's consider it not a symbol. We can make it a symbol, I think. So if it would be a symbol, what would it, what? Oh wow, what would it be? By the way, recursive modules won't work, huh? Or will they? Like if I evaluate, they don't have to infer. Okay, hold on, we've got a problem. If we create another module, we'll hit recursion. Mod 2. So we'll say test, which is a function that will call put s in it. So we'll have okay. Can we actually like have two things that depend on each other? We should have. Let's try it with function. First. Time test equals fn, which we'll call main in it. Nothing more required, and main will call test in here. This should compile and just panic. I mean crash and segfault, Stack Overflow, whatever. Let's see. It compiles and it doesn't. What? Excuse me? Oh wait, no. Expected semicolon got word compile. Wait, comp time. What? I don't understand. I do have a semicolon. Oh wait, I didn't save. Makes sense. Okay, now core dumped. This works perfectly. Okay, so if this actually doesn't exist, so it's somehow fixed, then it would be nice. So same recursion within modules. I actually don't know how it's done. Let me check. Symbol ensure evaluated. So it will. I mean, ensure evaluated does it infer stuff. It does, but so like, it's when it infers type, the thing that. Okay, so when it does type inference inside of a function, for example, if this function requires another module which is in the type inference phase, then it's just gonna say that it exists because it's evaluated. It has a concrete type, but its value, it also has a value, but the value is not yet inferred. Okay. So libc module. So let's see, test here. Libc test. We're actually super libc test. Test is a function. So this will be a function which can just copy it. Sure, you can mod 2, and we'll say this. This should just print and panic. Could not be found in superlibc. Okay, so what is that? Expected semicolon. So first of all, yes, semicolon, and here semicolon also. Ooh. Daedalus remaining. Oh, wait, Premiere. Making a simple dynamic memory allocator. What? Excuse me, I just researched it like really recently. Maybe we should watch it. This guy is actually like great. He did making an x86 OS series. Unfortunately, it was too late for me, but I mean, good that I know now. So yeah, we can actually watch this. Let's watch it. Some OS stuff. Yeah, that's so cool. I mentioned charity collaboration with Code Crafters. Doctors Without Borders. Code Crafters collaboration. Oh wow, that's actually interesting. You can close that, close that, close that, close that, and also, yeah, we'll watch it live. Actually, for this I will even switch to my main account, where I'm actually subscribed to them, just for the sake of it. Yeah, notify me, obviously. Nice. This injection, the best pattern. I actually don't know what dependency injection is. Okay, so this thing should work. Could not be found in superlibc. Symbol libc could not be found in super. Symbol super was not declared in the scope. What? Cannot be found in super to do. What? Oh wait, it's super action. Well, no, it's not. Huh? What? Simref. So with resolve, we do global, and so it does in the current module, and the current module is a module, obviously, which makes us resolve symbol in module, and if it's super, then we just return parent, if it exists, and parent should exist, or should it? When do we set parent in module? That's a great question. We actually would just evaluate it and set it. Like actually evaluate it and set it. Immediately. So it should be. Huh? Oh yeah, I forgot that I need to fix the logs. So ideally module would have a name. Come on. Could not be found in okay, so we'll add a name to a module, just at least so we can see what happens here, what's happening here. So where are we? IR mod res. Here's where the module is. Public parent name, which is do we say it's a string or it's a span? So name. Like it's for debugging purposes, really. We don't really need it as a span, so we can say it's a string. Okay, so how do we add a name? So in symbol we can set a name when we evaluate it. But can we do it earlier? I'm pretty sure we can do it earlier. So like when we create the IR itself. I mean we can, but uh, okay, so where do I start? Mm, let's go to parser. Parser mode res, which is where we parse a symbol. This just returns a symbol. So we construct a module at the end. No, we don't. But I mean, does this really matter? Expect operator semicolon insert symbol name. Okay, so here we insert the symbol. Into a module. Maybe when we construct a symbol we can fill its name. I mean, can we really? We can't because the module doesn't exist yet. So in the where is it? Yes, first of all, here we need to add the thing to the clone. Name, clone. Okay, sure. Now, now, so now we evaluate. Where we evaluate stuff, here we can just say that module equals actually like that. So this is a module name. Here we can say module. Okay, so module's name is gonna be symbol locked name as ref to owned. Yes, it's weird, but sure. Now, I guess so. We need to go to create now or call. Actually, the default. So if we go to module, no, if we go to IR mode. So unfortunately, we have to convert this to. Oh, derivative default. Oh, actually, we don't have to convert it because we have derivative. Default value, which is unknown. To owned. Yes, we're writing code and strings in here. Okay, so now this is a module. It has a name. Now if we go to close that, or calling lib, I guess. So we have our root module, which we immediately pin. So let's do let root equals so let's make it mutable. Mute. Name equals root. I mean, I can specify like the great name. I mean, I can't. I mean, I can hard code some stuff so from source we somehow get a name, but I'm not gonna do that right now, at least. So we have to do. Oh wow, super to do. Where is this simref? So in here we have to do. So in here we can just write module. We can just write a name. I mean, hopefully it's not gonna move it. Okay, seems like it's compiles. Okay, so what's happening? Symbol libc could not be found in libc. Why is super in here a libc? This is not in libc. What? So this is actually wrong. What did I just open? I don't know. In streamer body. Okay, refreshed. Shivering stream. Let's see. Mod 2 could not be found in mod 2. What? That's wrong. Like actually. Symbol test. Symbol A could not be found in root. That's right. Name could not be found in scope. Scope is a symbol reference. So what mutates its name? What? Why is it so wrong? Why is it saying mod 2? So this is actually like right. But then if we do super BA, I was gonna say symbol B was not found in B. In libc B, no. For some reason it says libc this time. So symbol B could not be found in libc. Why is it libc? Bro, like actually, what's wrong with you? Symbol reference. Something is wrong with resolution, I guess. I bet. So resolve global. So like actually I have well I have scope access. So I have symbol scope unresolved here. When I have unresolved, I resolve global. When I have scope access, and here it's unresolved. So just inside of it. So first we resolve global, which is super. In the current module, we resolve it as current module's parent, which is root. Then we run resolve scope symbol again inside of this root. Scope is root. Where do we actually found scope name, right? Alright. Like when we try to resolve a module inside of it, for some reason it breaks. Are we switching to VS Code for debug? Or actually, if we go to main.rs, before doing this, can we just print it create root? So just switch to it. Okay, so here super what? libc super okay, so symbol reference unresolved scope access. Oh, makes sense. I mean, this is just as expected. Obviously, it's not a parsing issue. Huh. Like, I actually don't understand what's that. Why is it so weird? Why is it saying symbol B could not be found in libc? Symbol reference. Span. Where am I getting the span from? Do I have a span? What? Oh, it's the span of the whole expression. Makes sense. Hold on, me. Is focusing on performance. I always wanted to write this honestly. Anyway, so there is a bug somewhere, which is actually really weird. Okay, so we have split it. Oh, hold on. So we have like between infer and finish and check, we have multiple things. Hopefully we're not mutating it. I mean, this might be it. So in finish and check we do scope access. So if the scope access I mean it is still scope access, then with finish and check types for the scope span type inference metadata. Okay, so we have shared metadata, I mean, sure. Mm, I mean, metadata. Finish check type. I don't understand. I don't understand the error. See, we go to finish and check types, which is also a scope access. Which we go to finish and check types of a module, which doesn't do anything. And so we're back here. So back here we report an error first for this, and then for this. For some reason it says libc. For some reason it says libc instead of root. Can we like debug the scope? We can. Yes. Scope is a module which holds a pointer. Where is display? Wait, oh, debug is just like that, yeah. Okay, so scope is a scope access of a module. Mod2. Scope is a module. Okay, so and then we have this. So first, well, not first. Let's just analyze this. Symbol B could not be found. Okay, now it says root. Again, printing fixes the error. Excuse me, but it doesn't fix the error here. Okay, so this is like really weird. I guess we hit the unsafe point. Now it says root. Because the scope is a module. So actually, where do we print it again? Should move it after we finish and check types. This would make more sense. Okay, so okay, it is libc again. So we go symbol B could not be found in libc, symbol A could not be found in libc B. So scope is a module. Isn't really a way to check it. Can we actually scope and then print a length scope with display as well, because with debug we don't get enough information. Who would have thought, who would have guessed this could happen, and I didn't save. Just clears permanently, nice. Like clears properly. Okay, so scope is a module which is libc. Why? When did this become libc? Like this time, how actually? How? Why? What? I don't understand. Like this actually became libc. for some reason. When during the type inference it wasn't. Or was it? So this was scope access. So here we could so we could put this in here and see what. Consider borrowing for instead of transferring ownership again. What? Oh, it's immutable. That's because it's mutable. Okay. Okay, so we have a root, libc, scope equals module libc. What? Which one of those are actually root? Is it, and which one is libc? Can I fire the metadata early? I think. Oh wait, I can't because. Oh wait, no, I can. I wanna report like. I wanna cheat and report it. When there is no error. So can we do this? No, we can't. Span is none. Wait, we can't say it's none. Symbol not found, scope span. What was that? Yeah, early report. Expected enum option found, enum borrowed option. What? Actually? It's like that? Huh? It's an error. Span is an option of. We need to clone it, okay. Okay, so now we have extra errors. So this is a root. Cannot be found in root. Mod2 cannot be found in root. Later we see this ends. When this ends? This doesn't end. What? Okay, so if we scroll up, we have symbol mod2 cannot be found in root. Then if we look for symbol mod2 errors again. Simplicity test. There are none. What? So it's not reported anymore. What? Oh my god, it was so loud. And I forgot about music. But we'll do without music, I guess. Yeah, I wanna watch this video live. Okay, so 2 minutes left. Symbol B could not be found in libc. Okay, so first of all, this error doesn't doesn't happen anymore. Okay, let's look for 8.3. 8.3 again. Now symbol test could not be found in libc mod 2. Because it's not a finishing part. But we still have like let's println finish Okay, so finish 8. So we have B in root 14.3. Okay, let's watch actually. Let's rest a little. Clearer minds. Why Jax isn't here?
In this video, I will show you how to design a simple memory allocator for your operating system. You will certainly know that in languages such as C or C++, the only way to access the heap memory, which is the part of memory that is not a stack, is to use functions such as malloc, free, calloc, realloc, and so on. In order to be able to do that on your own operating system, you need to write a memory allocator. The main things that the memory allocator should be able to do are: first, lend the programmer some memory on request, and second, allow the programmer to free the memory, that is, return it to the allocator after it's been used. The simplest form of allocation is linear allocation. You just have a pointer to a fixed location, and every time you allocate some memory, the pointer increases by the amount requested. The problem is, this way it is very difficult to free the memory. If the memory you want to free is the very last you allocated, you're in luck. You will just have to pop the allocated memory by decreasing the pointer. Notice that the data is still there, but the programmer is now allowed to overwrite it. If, on the other hand, you were trying to free something that you allocated a long time ago, you simply can't. Even if you kept track of the allocations and erased the memory, you could not reset the pointer to the beginning of that memory, because you would lose a bunch of memory that you did not want to free. Therefore, this stack-like method cannot be used. We need something else. A very simple implementation that fixes this problem is to use a bitmap to keep track of the currently occupied memory. The idea is that if a memory block is currently allocated, the corresponding bitmap entry will have value 1. Otherwise, it will have value 0.
Bitmap heap.
First of all, we initialize the memory, defining our total dynamic memory size. Then we construct a bitmap with 1 bit per block of dynamic memory. These blocks can have any size we want. They can be single bytes, which leads to fine granularity in the allocation, but high space occupation, or larger values, which leads to coarse granularity and lower space occupation. Trade-offs between accuracy and complexity are very common in computer science, and in particular in these allocation problems. We now have a bunch of contiguous memory blocks, and a bitmap representing them. The first thing we want to do is define what happens when we call a malloc, asking for a certain number of bytes of memory. Assume that the memory and bitmap are initially empty. If we call the malloc asking for a certain number of bytes, we want to allocate a number of blocks that is equal to or greater than the number of requested bytes. Let's call this number of blocks B. One thing the algorithm could do is scan the bitmap from left to right, looking for B contiguous bits set to 0. If the allocator does manage to find these B contiguous bits set to 0, it will set all of them to 1 and will return the memory address of the beginning of the corresponding block chunk.
Well, this is
If
more
the
like a
allocator
block.
fails, it should find a way to tell the user that it's out of memory. One important thing to notice is that even if the overall available memory is greater than the requested one, we may still run out of memory. This is because freeing memory can lead to fragmentation. Fragmentation basically means that the memory turns into some sort of cheese thing with lots of little holes, and no single spot is large enough to fit our new data, which would, however, fit in the union of the holes. One procedure that we can perform to get rid of fragmentation is, well, defragmentation. This consists of taking the occupied memory and bunching it all up to one side. The main problem with this is that it takes quite a lot of time. In general, we want to avoid defragmentation if possible. Then, how to do so? The main thing we can play with is the allocation policy we use. The method described so far, of just scanning from left to right until we find a free spot, is called first fit allocation. This is the allocation that our community work-in-progress operating system currently uses. Another possible method is what's called best fit allocation. Instead of scanning and returning the address of the first encountered suitable set of blocks, the allocator scans the whole bitmap and returns the address of the set that is closest in size to the requested memory amount. This leads to less fragmentation, but at the cost of a higher allocation time complexity.
Well, not
because we
really.
have to go through the whole bitmap.
Not a big deal. Forgot to mention, hey.
Given these basic operations, malloc and free, one can implement compound operations like realloc, which can copy a bunch of memory blocks to a newly allocated location of potentially different size and freeze the previous memory location. Hi, I have one last thing to say
What's
before
the point of
video ends.
realloc?
I recently set up a charity donation collaboration with the guys at Codecrafters. Basically, if you purchase their product with my link, a percentage will be donated to Doctors Without Borders, which is a charity that provides medical assistance to people affected by conflicts, epidemics, disasters, or exclusion from healthcare. Codecrafters provides a very useful tool that allows you to learn concepts in programming
Yes,
by
it's cool.
recreating some of the most popular programs and utilities, such as Git and Docker, in your favorite language with careful step-by-step guidance. Learning by doing
I
is,
really
in
like
my opinion, the most
Codecrafters.
effective way to
I mean, liked. I want to try it, but don't have time. I'm gonna leave a like, but it's kind of boring. You discussed one simplest block-based heap. Like, that's all. Let me close that. I hide it all. Yeah, but I mean, I'm gonna support it with a like, so we get more OS-related content anyway. Back to this. Why? So we need 14.3. 14.3. Here. Yeah, it's the same. Don't be found in root. Okay. So that means at least it's not a scary thing. I guess. Okay, no, symbol ipc cannot be found in root. 15.3. Symbol test could not be found in mod tool ipc. Okay, that's already wrong. So 15.3 in here. Yes, root, we ignore that. libc couldn't be found in root 15.3. And then we look for 15.3 in finish. That's not finish, but that's already off. We don't even do 15.3 in finish. What? Even 20, 14, 3, 15.3. So this is not finished, but this is in a mod tool libc. This is like already mutated. What? 15.3 and in here 15.3. I have a minimal example. So we only have twice. We only have it twice, and it doesn't even display in the finishing phase for some reason. Okay, can I like have a smaller example? Paste it here. Same mod. Same test super main. Okay, so we can run this, I guess. So oh, it's super libc test. This is not possible. Comptime mod module mod test. Okay, so I guess this works. No, it doesn't. Symbol main could not be found in root. What? Okay, so somehow I broke it. Last commit, except those two, was super colon colon. What? And what did we change? Okay, if I git stash, so we just call test in here. Then I do super main. Git stash pop compile sh. No, what's that? What will that do? Function libc main not defined. What? Function libc main not defined. What? Oh yeah, so this is off. This broke completely. Why is it libc then? Why is it libc? Okay, so git stash. Okay, so let me copy that. Git reset hard. Let me actually copy the whole thing. Then I'm gonna git stash pop. So we have this example, and so then we have this example. That okay. So here is a minimal example. Can I remove all of that actually? That's why I write tests. Oh, ads are playing. Okay, so super unresolved super. Since symbol main could not be found in super. Hold on, why is it unresolved? Oh, because it's not in a mode. Okay, so in Finish we have. We don't even have the message for the super itself. Oh wait, no, symbol super was not declared in the scope. We do have a message for that. Okay, now if we redo it properly, expected semicolon, obviously. Now what is that? Symbol test was not declared in the scope. Oh my mod test. Mod test. So scope is module simulate could not be found in root. So this time it's in root, but for some reason it can't be found. It could not be found, which is weird. Now we've got even more messages. Symbol main could not be found in the root. Then something symbol test could not be found in mod for some reason. Symbol mod was not declared in the scope. Okay, that's symbol test could not be found in mod again. What? So that's weird. And is it random? I think it's random. Yes, it is random. Okay, so that's weird. That's like actually weird. I don't know how to debug it. It's so hot in here. It's terrible. Too hot. Why is it so hot? Simple main could not be found in the road. Okay, so this happens when I return none. Where's my resolver? That's why you don't write and save Rust. Okay, so simref. Okay, so resolve global. I guess global is resolved. Its current module, which is super. So resolve scoped symbol. Can we print or actually debug the current scope? Remove print. Yeah. Welcome back, Nigel. We just watched a video about memory allocators because Daedalus was so there was a premiere which we watched live, and we have an error which is also random, which is I don't understand it at all. Like it's magic again. Symbol main could not be found in root. Okay, so in here, yeah, we should also print it. Actually, we should only print it. Okay, so symbol main could not be found in root. And the root is mod. Well, the scope is mod for some reason. Huh? If we go to the place where we call resolve scoped symbol. Where do we resolve scopes? We do it in here. Just so hot. I'm just losing my mind. I just can't do anything. Okay, so scope access. In here we infer types for the scope, and then okay, so we immediately report stuff. I forgot to remove the report. I mean, I can leave it actually. Well, no. I mean, I shouldn't really make it a report. Okay, let's remove it. So I have root and mod. Which makes sense. Here it's root, here it's mod. And then we have two errors in the order. No, not in order, actually, in the opposite order for some reason. Symbol mod was not declared in the scope. What if a new language comes that things vastly different from C++ Rust from perspective of high-level constructs? Yeah, the goal is for it to be possible. The goal is for it to be possible. And like actually, Orco IR. Originally, I wasn't going to include borrow checker in Orco IR, but I think it's such a popular concept that it should be like included by default. But I don't know. So the borrow checker should be implementable by the language frontend. To that extent, well, maybe even more. I am trying to get it as language agnostic as possible, and I'm not sure if I'm saying agnostic. Not sure if it's right. Like language independent, I should say. Okay, I can't. I don't understand any of this. Who wrote those dictionaries? Okay, so even if I comment this out, yeah, same thing. Symbol mode was not declared in the scope, which is weird. Symbol test couldn't be found in mode. If frontend needs to have row checking, that limits to only one language. But if frontend needs to have row checking that limits to only one language, you know that has row checking. By the frontend, I mean language-specific part. It's like we have Orco, and then we have different frontends. C++ frontend, like Rust frontend, etc. I'm not sure. I'm not quite sure what you mean by that. If you mean like, so Rust has references and borrow checking, and then there's like another language which has borrow checking, and you want to pass like a reference from Rust to this another language, will borrow checking break? Is that what you mean? Okay, so anyway, so why was it not declared? We'll comment this out. Will it be declared? If no, okay, it will. That's like super weird. So, I mean, ideally we would debug it in like Visual Studio Code, but I'm staying away from debugging for some reason. Maybe we should actually. Okay, let's actually open VS Code and debug it. Should be easier. Okay, so let's open mount dev tools. Orcom. Okay. Okay, so obviously trust. Okay, so we can go to source IR mod rs. So we start at patching Rust Analyzer for some reason. Can't clone from module, yeah. So we start at in front check types for the module, which okay, let's try to debug this. Did we debug Orco already? I think we did debug Orco already, so we should have configuration. No, we don't. Or do we? Okay, open launch JSON. Uh-huh. Huh? What? What is that? Okay, so args. Where's compile stage? Okay, so we don't care about logging, I guess. Okay, so this is actually like this is off. Okay, can I remove one? Delete, and let's recreate one. Let's recreate debug configs. Wait, cancel. Main.rs. Where's main.rs? Well, not main. What? Here. Yeah, here. Can I pin? Okay, create launch JSON file. Come back. Okay, debug. Okay, debug executable Oracle. This will be the only thing. We're not gonna debug tests. Come on, that's way over. Dash dash. Think. Paste simple Oracle. Und Orgo Oracle. Oh my god. Okay, this is the extension, okay. Sunbuzzer. I don't even know. I actually wonder what theme I have right now. So this, I'm dying. Is it okay, let me first, okay, so, first, I wanna see what, which theme I have right now. Everforest Dark. Yeah, redeemed. Oh my god, what? Why is everything pink? I mean, I like the code. This border may be a little too contrast, but everything around it is pink. It's like it's too light. It's like dark code editor inside of a light thingy. Virginia after that. I mean, I'm fine with working with that honest name. Okay, so where's their debug? That's not debug. Cargo invocation failed. What? Oh, it cargo build. Oh, okay. So this is then args. So what did I mess up? This comma? Maybe. So launch JSON is now not fine. Or is it? Okay, so we're here. Can I print self? Can I like display self? Print self with display. Maybe I should have added like display. Oh, self. Okay, parentheses might be invisible. Let's rerun that again. Cancel. Okay, I want to rerun it like that. Okay, so it's a module. Yeah, first we have main. Oh. So did it, I mean, it didn't output anything yet. And I guess... Oh wait, what? No, I am in the module. Hold on, restart. Like actually... Okay, so here. Step... Why step over? What? Okay, so the symbol is... Pointer. Inner. Not state. Or is it state to be 0? Oh, it's okay, data value name. Okay, can you just have a name? Why is it so bad? Java was better. Java debugging was much easier. Yeah, Orco should also support debugging, by the way. Okay, so whatever. So this is not evaluated symbol. I guess it's main because main is first in here. I mean, I guess let's go in. Should evaluate, obviously true. Okay, next. We log the symbol. What? What? What's that? Jump, jump, jump. Okay. Okay, so now evaluated is obviously none. We re-evaluate it. We do finish and check types. Then what is that? Type inference finish. Symbol. Oh, symbols type. Okay, makes sense. Then we. It's not abort compilation. Wait, we don't bring in. I mean, not do we need to? Okay, so we restore abort compilation. Now we go evaluate it. Click. So simple. Now evaluated. What does it hold? I mean, I can't really check anything. Error invalid value. Invalid value object. What? Okay, that's bad. That's bad. Okay, so it's not a module. I mean, yeah, because it's a main function. Okay, drops this, relocate, but as read. So it's function. We infer and check types inside of this function. So if we step over right now, I'm gonna put a break in here. But if we step over right now, we get... What is that? What is that? Okay, let's untick that, actually. So here we go in. Then old return type, don't care. Body infer types. So when I call, oh my god, so messy, so messy. let's redo it. Wait, I'm just dumb. Okay, so go in. Arguments, body, infer types. So here the body is a block, obviously, which is non-transparent. Then we go through each expression, and the first one is obviously call of the test function, and the output is already off for some reason. But here we call yeah, we call what exactly we call is a function, which is a symbol. Okay, the symbol is a scope access. Sorry. Where the scope is has a span. It's like the scope only has a span. What? So the scope, if we infer types, well, what is the scope of it? Like look at the output. If we try to look at the output, it's mod. Let's go in. It's unresolved. So resolve global should just keep set. Okay, resolve. Okay, now here, go in. Resolve scoped, which is which is a module. Wait, what? Okay, hold on. I messed up. I should have went into it. I wish there was like a step back. Why is there no step back? Like unroll the debugging. Where do we put a breakpoint? Let's put it here. Would be better. Restart and take as a breakpoint off from the function, then go to the next breakpoint. So here it's a scope access with the scope being unresolved, which we're gonna resolve here real quick. Okay. Here for some reason it is a module. Hold on. That's wrong. That's weird. Is it? It's not super. Why is it a module though? It should not be a module, it should be a symbol ref. Okay, so that's off. Hold on. Oh wait, no, it is a module because we're resolving in the current module. Makes sense. Get out. So this returns here resolve scoped symbol. Yeah, now this returns. So this returned as the module, I guess. Now let's infer the types for this module. Which module? I mean the symbol. Check for recursion, obviously not recursion, and should evaluate it now. So go into ensure evaluated. Should evaluate, obviously. Locate. So, what is that? Extend the path. You get the path of the symbol. Then we need to evaluate it. So we evaluate this module, and I think we can. Okay, let's quickly run through that. I mean, first we finish and complete it. Finish the types. Then here we evaluate it. Here it is a module, which it quits. Okay, so then if it's a module, we obviously set some parameters. Set its parent to be root, which is important. Is it true though? It should be root. Okay, so module, do I have a module right now? Data, value, name. Why we can't like see name? Print symbol data value name. Where is the debug console? Oh, here it is. Print data value name. I can't see anything. Wait, symbol. Oh, because it's a span. Can I call a function? Call. LLDB call function. Expert dash what? How do we execute a function and print the result? Point. Delete a breakpoint. Watch point. Come on. Examining variables. Show local variables. Content. X. Where's the print? Where's call? C class. There's no C class. Okay, so if I just do so I have print here without sref. So P should do the same thing, right? What about E? Okay, what if I add sref to E? No. P array. Paper color redux theme extensions. Okay, can I clean up in uninstalling this? Paper color redux theme. Okay. Latest paper colors. Why do you have so not much themes? Like if I actually just open my theme menu, it's wait, was it actually two? Maybe two. Doesn't really matter. Okay, so where are we? What are we doing in here? Hold on. Dark dinner. What are we doing in here? Where is the cursor? I don't think we are in the module. We are somewhere like evaluate something. Citizen symbol. Yeah, we're here. Okay. Where's debug? Debug. Okay, so how do I execute? Evaluating expression. Print int printf this. Want to see void returns call int printf. LLGB. Print int expression. Print string. Is there string? You see. Oh, I can select in here. Oh wait, I can select in here. I just can't see it. Classical problem. String. No. str. Char point. I don't know. Okay, so can I like actually call a function on that? Where's sref? std. Can I call a function from Rust std? Rust debugger print sref. Writing a debugger. Oh wow. Print call function from std. Quite limited with both of those. It's likely to cause problems. Only understands limited subset of Rust. Obviously, macros are not supported. I don't care about that. String constants and LDB expressions are created as C-style string constants. Easily passed. Yeah, sure. Crashes this thing. Okay, I guess we're not gonna know what this is. But I mean, if we go to terminal, so I guess this module is just mod. Should be just mod. Anyway, so here we set evaluate, drop it, and reopen it. It's a module. So we pin it. For some reason. Wait, what? Why are we pinning it? Okay, so symbol locked is. Oh my god, shift viewers get out. Banned. Symbol locked. What's the type of symbol locked? Alt key to switch to editor language hover. Okay, I wanna see the hover. Is RW lock? Oh wait, actually, the symbol is itself is. I mean, it is pinned, I guess. I don't think I can move it. Current module, memory place, current module by this. Okay, so this is actually dangerous. So module is a reference to a part of the struct which is evaluated. So internal pointer of a module. Can I like watch an address of in a memory? LDB watch memory address watch watch point set global variable set variable global var watch point set expression dash dash pointer. Okay, let's try that. Watch point set expression dash dash. So the expression we want to watch is module watch point one address watch module module. Okay, so module is just a pin, so we can look at it like that. So symbols size 1. So this is the current module. Yeah, here we set it. Did we just change it? No, we didn't. Did we? Okay, so just pass. What? Here we push and then we do 0.pop. Okay, I guess. So go here. If we go to the terminal, go over this line. So we have just a module which has a test function. Ensure evaluated. Can we go here? Obviously we can. So this function, let's just go through some of that boring stuff. Be careful not to go too far. So we need to we need to skip its evaluation. Evaluated. Then we have this. Yeah, we need now function. Here we infer and check its types. Which let's go into the body. Infer check types. I mean just infer types. Right now, doesn't matter though. It breaks. Before that, so block. Now the block has a single expression. Could not find item. Okay, it's dead. So where is it? Self expressions. Yeah, has one expression, which is just a call of a main. So let's go into that. It's obviously a call. So let's go here, and this is the simref. Which is scope access, right? So now we go into that, which is unresolved. we're gonna resolve it. So this is super, right? So in here we just go through that. So this is in the global scope, which is yeah, this is a global scope. So in here we check for super, and yeah, we return that. What's wrong? Redundant. And you're telling me about that now. Okay, sure. Hopefully this won't mess stuff up. Okay, so this thing, we go out. So we resolved it to be the root, I guess. Yeah, and now we infer types of that, which shouldn't do anything. Yeah, it doesn't do anything. So here we go to scope access. The scope is root, right? And so we have data resolve scoped symbol, type inference scope name. Okay, so resolve scoped symbol. Yeah, sure. So here the parent is module because it's root. Now the name is main. So scope is root. Symbols. Okay, hold on. I mean, it has main, but the symbol is not like resolved yet. Okay, let's get out and see what happens. Self equals symbol. So we're setting self to main. Yeah. Infer types of the symbol. The symbol is obviously a symbol. Check for recursion. Yeah, we are not recursing. And sure evaluated. Now we ensure that our main function gets evaluated while we are evaluating test function. Well, no, not while we are evaluating test function. Test function is read only. Test function is evaluated already. So here we should evaluate obvious. No. What? Oh wait, we were evaluating from main function. No, it is evaluated already. Main is evaluated. And main was inferring. Okay, now we get out. We get out of here. Get out of here. Okay. Infer types. That's for the call expression. Okay, so we've inferred types for our call expression. And we have actually our main function, which gets modified right now. Then we have type. Okay, yeah, we have some problems with traits. That's gonna be a problem, a big problem. Okay, so infer types. What is that? Yeah, it's a block. Get out, get out. Okay, so we inferred types in our function. Okay, let's step over. Okay, it's all fine. Then we get out. we've evaluated our main function, which means time to get out and go to the next symbol. No? What? Oh wait, no. Wait, what? Oh wait, this was test. We still have stuff to do. Yeah, now we need to go to main. Well, no. Do we? I don't even know anymore. So this is from main, because main was evaluated. Yeah, this is from main. Welcome back. Still debugging here. So this is scope access. So this is gonna print. Wait, what? What am I even doing in here? Wait, what? What am I doing in here? Excuse me. And what is gonna print? Mod. Huh. Didn't we just do that? Oh wait, we... Okay, I think I know what happened. Okay, so self-infer types. Maybe I know what happened. It's so complex, it's hard to keep in mind. Okay, so this is the symbol. This symbol is a reference to test function from main function. I think ensure evaluated. Let's go into it and see. It should be already evaluated because module. Yeah. Now we just get type. Okay, so this is what is this? This is a symbol reference from a call from main. Okay, so now we're gonna get out of main and go to the module again, right? Where am I even? Call. Yeah, get out of here, out of here, out of here, out of block. Okay, we've inferred types for main. What is for the function? Wait, no, get out. Get out. So this is ensure evaluated of our main. Can feel like we're here already. Since the rain start, right now it's like very rainy. This rain started in like 2 seconds. Wow, so it's so like it just started. It's not gradual. Okay, so now we're evaluating another symbol. But oh wait, I got out. Okay, so we did evaluate it. I mean, wait, what? Get out. Step out. Okay, can we just continue running? What? It just compiled and didn't do any. What? I don't understand. Debugger just gives the wrong output. Yes, I don't understand what's happening. I like actually debugging gives a different output. Don't use debuggers. Or oh wow, it is random. Okay. So in this case, what evaluated first? Main evaluated first, just like we looked at it before. So here it's errors. Here it is. We need to step through another debug process, which will work in 50%. Okay, what? Now we're getting extremely lucky and it's working again and again. What? Okay, so module has a test function. Let's I mean, I don't know. So let's do the ordering. Main rs. Wait, no, not main. IR mod rs. Here are the symbols. We can switch this hash map for B3 map to get some ordering. To be able to control ordering. And where is simple. So now we call this mod A so that it is always first in this B3 map. And then it should be reproducible issue. Yeah, that's how hard compiler development is, see? Respect the LLVM team. They are doing incredible work and they don't have Rust, which prevents them from a lot of problems. Simulate was not declared in the scope, yeah. Okay, so this is weird, honestly. Let's debug. I so don't want to debug it, honestly. I'm so tired. Want to eat, I'm hungry. Okay, so yeah, this is a test. We go in, this is unresolved. We can resolve it. It is so we can go here. It is gonna be module. Then I clicked. Okay, I clicked the wrong key, the wrong button. Anyway, it is resolved. Okay, let's redo this. Let's do it again. Go into infer unresolved. Go into resolve. Go into. Okay, let's go here. Go into that. Okay, so in here it's not super. It is super what? Oh wait, yeah, we're doing this. So it is actually super main. Okay, so the scope. What is the scope? Anyway, we get out of here. We resolved our global symbol, so this is now root. Which infer types we saw this already. What? Okay, so here now it says root in the terminal, right? Root, okay. And then we resolve scoped symbol in it. Root is a module, yes. It's not super. It should be one of the symbols, one of the items. So scope symbols, lens 2. Yes, and it has main, right? So the return type. Can I watch like the return type? Scope parent none. Oh yeah, because it's root. Can I watch the return type? I want to see the return type. It should be not none, it should be some. So this should return some. Okay. and we infer types for the main function. Now, the symbol reference to a main function. Okay, skip the recursion check, ensure evaluated main function. Great. Now we can go to the ensure evaluated itself. It obviously should evaluate. Then we do some stuff. Yeah, we infer it, we evaluate it. Where is the evaluate step? Come on. We evaluate it and then it's not a module, obviously. Then we go where's the function specific, infer and check types for the function itself. All return value, we don't care. Type inference scope. Okay, push scope, where are we? Oh yeah, body infer types, that's the main thing. Now this is a call expression. Oh wait, no, this is block first, and then a call expression. In it here, call. So, ooh. Okay, so yeah, call of a symbol, which is a scope access. Let's go in. It's unresolved. Let's resolve it together. It's not a variable, obviously. So let's globally resolve it. It is module here. Its name of the item is not super. Where is it? What are we inferring now? Yeah, we're inferring it is super. Is it? No, it's not. Huh? So we started with oh wait, we did print already something. Symbol mod was not declared. Okay, I skipped the time where we printed this. Huh? Where are we? Wait, I'm here. Here's the debugging step. No? Yeah, we're here. Huh. I don't know where we are. Anyway. So, what are we doing? First we evaluate module, I think. Yeah, first we will evaluate the module, which asked us to evaluate main, which asked us to evaluate module again, which asks us for main. No, it doesn't. So this is not super, so this isn't main. Let's just continue, I guess. So this returned some, right? No, it returned none. Okay, so what is that? I don't know where it is, but it is, I guess it is in main. Let's get out and see. So it's scope access, since this is an error. But the scope is A, but it's unresolved. For some reason we could not find A. Okay, don't know how we got here. Let's retry. So this is in A. We resolve, so this is gonna be again. Okay, so this is, so if yeah, I don't know. I don't know where we are. I don't know where we are. Okay, actually, good way to know where we are would be to open symbol rs, and here where we evaluate stuff function, so let's print ln in function self well, not self, simlocked name as ref. We can even do this. For quotes, so okay, let's restart and see. So here we are in where? We are nowhere. Wait, what? Okay, so I think we have a little too many prints. Print license report. Okay, so this we can remove it. Okay, and this scope access, yeah, we can leave that. Okay, debugger, come back, debug. Where's the search? Search, we can remove that. Okay, debugger, compiling stuff, okay, debugging. In function test, we are just fine evaluating stuff. Yeah, this again. So resolved. Get out here. So we are resolving main, root and stuff. Okay, so yeah, root main, and then in function main we try to resolve function test in a module. Okay, let's see that. Unresolved. Resolve global name. So this is the what fails for some reason. Resolve scoped. Name is super. Oh wait, no, it's not. So here scope has one symbol. Yes, that's right, because we have or is it? Hold on, no. Is it? So that's not right. Hold on. Why does scope have one symbol? Let's try again. In function main, we resolve, this is unresolved. So that so this is obviously false. Okay, so this is we resolving A, module A. Okay, so this is the module, right? It's not super. So the scope should be why does the scope have a parent? Okay, yeah, that's wrong. It has one symbol, so this is scope. Scope is A, and we're trying to find A in A for some reason, which totally makes sense with error messages. Okay, let's restart it and try to figure out why it is A. Why the scope is wrong. Current module is A for some reason. You know what? I might know why. If so, it will be such a stupid mistake. So maybe we don't unroll the current module after we evaluate it. I mean, we're literally doing it right here. So we replace the current module by this module, and then we roll it back to root. Okay, let's try debugging it, actually, because I'm not sure. Okay, go to main. Okay, scope access, obviously. So this resolve global symbol in the current module. So type inferences current module, not root module, current module. Should not have a parent, but it does. Oh, I think I know what it is. Okay, this will be impossible to fix. So we need to evaluate main first. Okay, so my lazy evaluation scheme doesn't work. Okay, so yeah, this is what we should have feared about. Global design flaw. So when we evaluate, let me try to show it maybe somehow. Simple. So where? So here we first evaluate this. So we go into module A. We go function test. Yeah, we need to evaluate. So we've evaluated. We need to evaluate now main, because it is a dependency. So it gets lazily evaluated inside of module A. And it is considered that the main function is inside of module A, and then it tries to resolve module A. So if we remove A in here, it's gonna work. Or is it? Function A main is not defined. Oh yeah, everything's gonna go wrong. Okay, so yeah, I don't know how to fix it. By the way, should we leave B3map instead of hash map in order to make random issues more reproducible, but then they won't occur randomly? I don't think so. Okay, so imagine testing where you run a test a few times and it passes like one of them and you say, okay, it works. Yeah, that would be weird. Weird. Okay, so what are we gonna what are we gonna do? Cause like I don't know how to fix it. I like actually don't know how to fix it. We can either try to get rid of lazy evaluation, but I don't know. Like the problem can be generalized. So imagine this module evaluates first comp time x equals. So this module evaluates first. So then we need to reference something from super. And so this is this is an example that's more general. So this is like from another module, or I don't know. You can even say y and do comp time y equals 10. And if I comment this out, if I return so if I return x, okay, so can I also comment this out? So here I return x, then it's gonna return 10, obviously. to do. Oh, come on. No. No. Yeah, we can't have symbols. Comp times like that are not supported yet, but will be supported. So if we would be able to do a.x, if we would do a.x, then it would break. Just in the same way. So we can't just like remove lazy evaluation. Okay, so then we need to fix lazy evaluation. We need to evaluate in the right context. So we have a reference to main to x here, and we need to evaluate x, which means we need to switch the current module to the. So we need to switch type inference as context. What does type inference have? It's like type inference is like global context of compilation. That's more like it. Return type of a current function. Yeah, I'm trying to fix it, but it's hard. Like I'm trying to, for example, when I'm calling a function, I'm breaking it all up. So yeah, the whole thing of lazy evaluation is flawed. We'll need to fix it. So when we actually call evaluate symbol, maybe we should even create a new type inference context. Yeah, we'll also need to think about it so it works with multithreading. It's gonna be such a pain. Okay. The interpreter can be cloned or shared. Well, can it be shared really? Like interpreter will hold a scope, so it can't be shared. Or will it hold a scope? Okay, I don't know. Type table. Yeah, that's type inference stuff. This has to be shared, like pretty much. So I suggest. Suggest. I guess we will try to take a big chunk of the struct out as a current context that is not like global. Global is, for example, a type table. This is global. Interpreter, I think it can be global if it doesn't hold a scope. Reporter is global. Return type is obviously not a global. Not global. So the like local context. We'll need to rename type inference. I'm so tired. I don't want to be doing that. Okay, let's go to readme, I guess. It will be easier for me to do here. Fix design, fix lazy evaluation. Let's make ourselves a tiny roadmap. Can this be nested? I need to be in org mode. where it can be nested. So here, first thing we need to do is rename type inference to something like context. I don't know about this one actually, because we need to also rename functions. What does it do except type inference? We evaluate comp times except type inference on this stage. I don't know how to call it. We'll worry about it later. Then we need to extract part of the type inference context struct into a local context. So there is a global context and like a local context. Can we take a look at type? I mean, we can take a look at type inference. Type inference modulus. So return type is obviously a local part. Reporter, I mean, they all also need to make it multi-threadable, which for best performance would mean cloning. Let's insert the Smith step in here. Remove lifetime. So we can like share it. The reporter would be like an ARC of a mutex. Interpreter, I don't know yet. I guess it can just be like a borrow, an immutable borrow, because this is interpreter context. What will it store? Some parameters? Maybe a scope? I guess it will store a scope. This is problematic. Like, this part is problematic. I guess we need to do this first. Okay, so yeah, interpreter will probably be local. Type table will be probably mutex. Yeah, this is obviously local. Abort compilation. Good question. I guess it's local. Because we set this flag when we encounter like a terrible error. Then we have okay, so I also need to keep in mind a few things. So let me think. So much stuff is going on in my brain. It's so hard. Uh, hmm. Okay. It's gonna be hard. That's gonna be hard. Anyway, abort completion is local. Scopes obviously local. Next step variable ID global. Next variable ID local. That's actually like scope related. So yeah, we have the local context. Isolate local context. Something like isolate local context for all ensure evaluated. Okay, so that's now imagine a big function. Can we like parallelize its? That's what I'm thinking about during this during writing of this document. I'm trying to find all the problems. So can we parallelize well, not evaluation. Well, we also need to parallelize evaluation. But can we parallelize compilation of a function, or this, I guess this step of a function? Uh, okay, no, not really, because there's an order in it. Okay, bring this back. Bring this back. This will be required. This will be useful actually. So now if we think about if we think about how can we do that? Can we do that? Can we run crane lift? Can we invoke backend before we even finish inferring types? Because that's a great question. maybe we can. Like if the function has been fully inferred, the single unit, the single symbol, maybe it can go to crane lift. By fully inferred, I mean dependencies as well. Okay, so there's one last thing. Which is a problem. Function struct. Functions don't have signature in their type. So if we open simple Orco, that's why we even evaluate them. That's why we evaluate them. So the type of this test variable, well, symbol, is just function. Because types are stored inside of a function. And even with traits we can't have typed things. Well, can we actually? Actually, if we go up, if we go up to trait, back to print, so can be a function pointer actually, not just a function, because that's what we're gonna see it as. But then this is a constant. Yeah, this is a constant that we can define. It's beautiful. So we can create a trait. Can we make trait a symbol? If we can make a trait a symbol, then we can then it would be so cool. Yeah, we're definitely not doing what we should. So if we can make a trait, a symbol. So what's this? This is the type of a trait. Type is trait. It contains list of mappings from name to type, and maybe even default value. Then we go through. So if this is it, then imagine we implement. How do we implement a trait for a type? Imagine I have a type. Hold on. How come we have traits when we don't have types yet? Okay, let's imagine we implement a trait for a built-in type. Trait for usage2. Print is a function. It's not a function that takes self, which will be this will be a problem. Yeah, for that we'll need generics, or well, kinda generics. This is the hard. So yeah, for traits we kinda need generics and structs. So I guess we delay the traits. So we bring structs in here. What is generic? Generic. No, there are no generics. Generics. Yeah, we're pushing traits away from us. But imagine generics. How they're gonna work? As construct. So imagine there is a struct which has. So struct can have fields. It will emulate traits in here for a moment. Well, no, let's not. Let's say this is a vec2. So this has. Why is tab so weird? Because this is commented out. X T Y T. And so how do we say generics in here? So we like in a normal language we would do something like that. So this basically duplicates in the back end, but we need it to work with type inference, so we can't do it like Zig did. Or can we? Well, maybe we can, but it would be annoying. Or will it? So like actually, what Zig has what Zik has this as a function. So this vec2 is actually a function which returns a struct. So it's a fan of type t. Well, actually, yeah, t type, which returns a struct, and so it returns struct. Yeah, that's crazy, kind of crazy. But that's how we could theoretically do generics. And coming back to traits, so there is self-argument. T. Since that's tracing, yeah, I kinda don't really understand how it's gonna work. So there will be a function that yields the trait. Okay, no, that's not a good idea. So how the self argument is gonna work then? Well, self is a pointer. Doesn't really matter to what. I mean, it does matter to what. Self, which is like an abstract type. Well, we can do comp times self, which is a type, and print, which is a function pointer, which takes self as an argument. That's what we can do for a trait. So associated types and generics are different. And so yeah, makes sense. Okay. So how would vec2 would be useful? Just call vec2 of t i32 equals vec2 of i32 colon. Well, colon to access what? How do you make me new? Ooh, Rainy went back again. Came back. And birds are here. SLBSH. Hi. This is non-shard. This is not a language. This is a text representation of intermediate representation. No, this is a text version of intermediate representation. Yeah. And it's much higher level than shard. Because shard aims for more of an assembly, and this thing is designed to be high level, basically. It was designed to be high level on the outside. Yeah. So this IR is not just IR. It was designed to be high level on the outside, but not on the inside, because it's an IR after all. And on the outside it is high level, so multiple languages have language interoperability. It's hard to explain, but yeah. It is a high level intermediate representation. It's not a unique idea, by the way. High level intermediate representation. Well, that's HAR in Rust, I guess. No, it's not a language. It was not. I mean, okay, you can call it a language, sure. LLVM is also a language to some extent, and assembly is a language, and shard is obviously. I mean, shard is a language, you know that. But the point is, you don't normally write in it. I write in it because it doesn't support any frontends yet. It doesn't support any language. No languages can compile to it yet, so I have to write it in text. And yes, it has types. Yeah. It is high. It is so high level because I need language features to be like native in it. Some language features to be native in it. Yeah. There's still no syntactic sugar. That's one of the rules. Okay, so new. How can we do that? This is a type. A struct is a type. No. Can we say a type? We should be able to say a type because honestly. We can probably do same thing we did with functions and function pointers. Because the type of the vector is this, but comp time vec2 f can do vec2 float. What is it? This is actually gonna return a struct, but we need it to return a type. Huh. Okay, that's so much problems, so hard. I mean, we can call it. I don't want to call a type. So I don't want to call. I don't want struct to be a type, honestly. Cause then, like, then it's just gonna disappear basically. So if this is gonna be a type, and I want this to be a struct, but if this is gonna be a type, then I mean it is a type alias. I guess it will be considered a type alias, and so I mean, who cares? I care, because C headers or C++ headers, which is even worse. Yeah, we've lost it. We're lost in it. Okay, so type. By the way, did I no, I didn't close the tabs. I mean, I can just close it all. Okay, so type. We have this. Towards this. So then it's hold stuff. Yeah, we won't get struct. That's so hard. Designing stuff like this is hard. Implementing it is even more work. So for simplicity, this would be a type, honestly. But then a problem. So this should be defined as a struct, but it is a type. We can define it as a struct, but then if I say this again, and then this is also considered a struct, which it shouldn't. It should be a type alias. It should be just a type alias, which I mean. Can you really say it's type alias? This would be so complex to implement as a type alias, honestly. So maybe we should like keep it as a struct. Not gonna go go anywhere except headers anyway, and headers are, yeah, headers are problematic. So, what? Oh no, come on. You don't give some clarity. I don't know if anything is gonna give me some clarity, but yeah, I guess I'm gonna do the push-ups. Do you think if I would be doing push-ups slower, it will be easier? Maybe I should like intentionally slow me down, like I do when I'm running, because it's hard to run. Okay, so we'll worry about headers later, I guess. So then, if we do I'm gonna do exports. Okay, so oh god, the rain is so strong. People are just walking under the rain. Yeah. Okay, so yeah, Nigel, as you can see, we're doing some design because I don't want to be hitting too much design flaws. So yeah, we didn't yet decide how is this. What? What do you mean? What? We hit a global design flaw, but I mean not design flaw of the IR. But I don't want to be hitting design flaws of the IR even more, because right now function in IR doesn't have a type, and that's a problem when you have first class IR. So main's type is function, but when you reference it somewhere, for example here, its type is gonna become a fan pointer, which is different. And yeah, speaking of that, maybe let's do something about this. So modules are just modules. Wait. Can't say anything. Give up working on your language. Why? Why did you do that? Why? It's not that hard to design a language. Okay, so those are just values. I32, I guess, will be inferred by default. Didn't see any use case or purpose. Okay, yeah, that makes sense. X is just gonna be inferred. So, not worth thinking so much. I mean, I have an excuse for this IR and the whole Orco thing. It's written in the README as the whole README. Okay, so do you think we should keep here function or actually change this to something like to type thing? So it should the function have types? Should functions type have type? Have a type? I mean, have a signature in it. Sure, I don't think it should because so when we do this on the Rustland inside of the thing, main is gonna have a type something like Orco. Let's just simplify it. Orco function or IR function, doesn't really matter, and it's gonna have a generic. Because of this, args are gonna be So the first argument of generics is gonna be args type, and the second argument would be like a return type. So that's how it would be in Rust then. And as you can see, I can't really store this type, nor I can construct it properly. So like that's why. And same thing if I want to do like macros in here. That's why function type is does not hold a signature, but this gives a lot of problems. This creates a lot of problems. So in this configuration, function contains a signature inside of its value. So what if you want to implement a trait? I don't remember what was the problem with traits. Yeah, so for example, trait contains associated items. So self, which is a type, for example, and when you implement the trait, you're gonna have. Wait, remove that. Traits is just one example, one tiny example. When you implement a trait, you're gonna have to define them. Equals util2, obviously. Because this is a high-level intermediate representation, and if I want Rust to be able to interface with it, then I need traits. Because imagine something written in a language that compiles to Orco, and then you execute it from Rust. If this language had traits, you probably want in Rust to use those traits. That's the whole point. Or imagine just even a simpler example. Rust compiles to Orco, and you have two crates. No, it's not equal. But no, it's not equal. I mean, we need traits because that's a feature. That's a feature that we need to support, because one of our languages is gonna probably support it. Like instead of traits, I could have done like what? I mean, operator overloading is a separate thing. Yeah, but I'm not gonna support every single feature out there. Yeah, there are some problems with it. There are, but I mean, traits are just useful in general. Virtual construct. What is a virtual constructor? I mean, they are gonna be possible probably. But what's a virtual constructor? Can you remind me? I haven't used C++ in a while. Why constructor should be virtual? How can you, like, virtual constructor means you can override the constructor. Like, what? The constructor is virtual. I mean, how is it different from a virtual function? From a regular virtual function? Well, in C++ it's not, but if we consider that it actually returns the value itself and doesn't take it as an argument, then it is indeed different from a virtual function. Constructors are different from functions? What do you mean? Constructors are not different from functions. If you look at Python or JavaScript, they take it even one more step further and say that constructors are just normal functions with special names. In C++ it's the same. Constructor is a function. It's just a function that has some syntactic sugar on top of it. And we all know that syntactic sugar is on front-end side. And if we want the syntactic sugar to be shared, it's inside of metadata. Shared between languages. Yeah, that's hard to design a language for all of that. An AR for all of that. But traits are just a useful feature, simple to implement. If the syntax is different, then thing is not different. It doesn't mean that thing is different. Syntactic sugar is a thing. And if you desugar a C++ constructor, which is desugaring is front-end work. So front-end desugars it, and yeah, they are different. Front-end is gonna frontend is gonna desugar it and put it in the IR in the sugared way. Hi, Davninia. Hi. We're trying to have a discussion, and I'm dying here. I'm not calm. I'm going crazy. So you're back to functions. Can we say that this is a function pointer? True. Can we just say that this is a function pointer? So this is a type. Don't mess it up. It's a type. So if it is, then this whole thing. So this whole thing is a function. I mean, if it's a function pointer, it has to be pointing to something. Can we like leverage ARC's shared ownership again? I mean, we need to generate this function in the backend. That's the problem. Maybe evaluating this puts it in like in a backend, in a list. I don't know. Or maybe shared ownership is a good idea in here. Same as we did with types, but okay, so the backend contains only functions. So that's what we need to look out for. That's what we need to look for. I mean, I don't really like. I want this to be a function. So function type will still be there. Okay. Can we actually start implementing that? Rename it first step. Yeah, well, we can skip renaming for now. So let's remove everything that's not. Oh, hold on. We didn't finish this part. Which is it basically associated item associated to a type. What are you? Why are you asking that? It is coming. Sorry, hit my microphone there. See here we can just input. Two less. 8.8k. I mean, that's not bad. When did it become affiliate? A month ago. Okay, for a month it's not much. It's too small for a month. I think even more than a month. Yeah, more than a month. Why, Nigel? Where are you spending all your points? Why is it so not much? On Freedom's channel in 2 months I got 80k. And in 1 month you got like 8.8. I mean, you spent quite a bit, honestly. Considering controllable plushes and all those redeems, which I need to accept again and again. Oh, gap style. Do I have it? Hey, why can't I see gap style? Yeah, makes sense. Okay, did I remove anything? Okay, so this is pretty much like traits, but not traits. Tell me like anonymous impl anonymous traits. Or okay, so implementation can be something. What we need is function. Do we really need that actually? Like it's associated to a type. We can try impl trait. No, not trait. Or function, or don't really need a trait. It as a trait. Means it's just a set of functions associated for some reason with this function, with this object. Hold on, not function. Vector. So function and t type, which returns an impl t. Yeah, that's weird, but makes sense. Who made me go first class? Anyone in chat? Can you show this person? Uh, it has started. I mean, I guess I did. Okay. Yeah, why did I go first class? Why? To support more stuff, I guess. Because it's simpler. Generalization is good, right? Or wrong? So impl is here, impl is eh. Yes, I mean, like, it's not much different. So if we just finish writing this, fun. I don't have traits yet, and we pushed them aside because some more stuff needs to be implemented before that. Okay, so like traits are a good generalization. That's why I decided to add them, because you can generalize operator overloading, casting, and everything like that into traits without losing the language part. So I can have traits and still make it work in C++ with C++. That's why I went with traits. But if I would go with C++ concepts, because there are just multiple ways, multiple different things which all could be replaced by traits. And yeah, inheritance, which is not possible in Rust, is something we also need to consider. Anyway, if we go back to this return. Okay, so this is basically the same as doing something like back new of t type. This returns a function returns a t. Oh no, vector t. So this returns a function again. I need to write it again, right? And so this function just returns this. Why did I use my mouse there? Okay, so this is basically the same, except that this is more other languages friendly. Okay, let me think about it. Like the difference is impl, and why impl is here. It associates a symbol with a type, and trait impl associates symbol with both type and a trait. Now imagine another example. Just switch context a little. Good old C++ example of inheritance. This is the class. This is structure classes. Same thing. So this, whatever it has some data, which is, let's say, integer, then we need to inherit from it. So this is impossible to do with Rust. And we need this to be possible in Oracle because C++ should be compilable to Oracle, obviously. And hopefully we need to do this without like generating more stuff again. Oh, and yeah, this won't really work. I mean, this works with Zeek, but won't really work with how I would implement it. Because the function returns a new type, so we need actual generics. So imagine just we had the syntax for inheritance. I mean, we could also do this with functional. Creating a function, or actually not a function even. We can do time inherit function type, which returns a new type. Let's just say it's something like. Oh, okay. So this is just my thoughts expressed as text, which I can't even understand what I'm writing. So I guess this is how it's done under the hood. Kinda. So first it is a struct. I am starting to go insane. So we're redefining it with additional animal. So what we need to be able to do is to convert it. I mean, we can turn to composition. So just have oops, animal. Okay, we don't need that then. This is how we could do it under the hood. If there was under the hood, except that everything is not under the hood. Everything needs to be pretty for all the other languages to look at. That. Let's imagine for a moment something unthinkable. We let's imagine that this IR becomes low level, but still first class. How this is possible? So then this is valid. I mean this is also valid, obviously because it's first class. Where are implementations? Yes, this becomes this basically. Then yeah, this is just also just first class stuff. This becomes like new. I yeah, this is this is weird, but it is it. Okay, yeah. So let's like not instantiate the macros. We can call this a macro. Because then it would not it would make no sense at all. Or will it? Oh wait, this won't work. I forgot. I forgot that generics don't work like that. Okay, so imagine generics first. And so what's there gonna be converted to? Okay, we can't get rid of generics. Because it's just copy pasting. It's templates, same thing. And we can't really replace generics by functions. We need to. How is this possible? Like, how is this even possible? How Zig does this? Because Zig does this. Zig does generics like that. Yeah, here is an example. I mean, can we? I don't think I can understand it like that. Uh, Libraries. Air. Okay, so where is the AST stored? AIR. Types resolved. What is that? AIR link. What is AIR? Analyzed intermediate representation. Okay, good, pretty good. Inst. What is inst? Tag. Argument add. It's what? Is it like this add thingy? Breakpoint. Okay, no, it's not. What is that? Add try. Okay, so this is an instruction, whatever. Data union. Oh, it makes sense. So those are this is an instruction block. Trailing is a list of instruction indexes for everybody len. What? Block holds only length of body. What? Debug inline block. What? Call only holds count of arguments. What? Why? Trailing. What is trailing? Something that is stored after that? I guess. Bin. Yeah, so I mean, I'm probably not gonna understand how it's done in Zig. Where is freedom? Freedom should be live at this point. Freedom. Oh, here he is. There he is. I guess I'm gonna raid and think of it off stream. I guess I will go eat, clear my mind. Stop overcomplicating things, hopefully, maybe. Because there's like one more way this can be. So I don't have to support every single function. There is one more way it can be done, which is weird. But if I just say that each class, each like class member will get converted to a function vec colon new. Say that this is a convention and this is just a name, a single name. Then it's gonna kind of work, because every single thing is following a convention, or actually even like we just do that vec under name. So if I say that for example, in Rust, impl vec fnu will get converted to, and borrowed self will get converted to this. Self is a pointer to what? Pointer to vec, obviously. Okay, let's just remove that. So if I say like this Rust code will convert to this IR by convention, and so will this C, C++, I mean, and so will obviously this C. The C would be like just vec new, which has self or this. I'm gonna call it that, which is a vec pointer. Oh, that's not how you do stuff in C. Hold on. This is how you would do this in C. So if we say all of those three examples, so this is Rust, this is C++, and this is C. So if we say it just works on conventions, then it's kind of gonna work. And it's even easier to integrate with C, for example. But then it breaks if you say, like, it kind of breaks if you say, like, vec underscore underscore new. If you, like, actually say this in C++, so if in C++ you say int main, you can call it, like, right, as a normal function. And then you can define stuff like that in C. You can like actually define vec underscore underscore new in C and use it in Rust. So that's not how it normally works. Yeah, but I think this is a cool way. Maybe actually continue. I think we'll continue tomorrow. You know what? I think I'll prepare a list of features. Yeah, I know Freedom is live. I said that he's live 4 minutes ago. So I'll prepare a list of features, and tomorrow we're gonna try to write them in different languages and different on different levels of abstraction. Anyway, I guess we're ending now because I wanna eat for like past 2 hours. Right, that's how stuff works. What do you want? It wants me to collaborate so badly. By the way, guys. It starts in 40 minutes now. What? By the way, when I get to 100 points on Freedom's Twitch channel, 200 milestones, 100,000, I'll redeem Putin game for him to make a custom overlay, and we're planning to stream this together, like using Twitch's guest star or whatever it was called. Not sure if it's possible, but hopefully it is. Okay.
Yeah.
Wow, this is slow.
Yeah.
Yeah, this would be cool. Because I have my own overlay, my own overlay in Godot, so I'm gonna be teaching him to make something like that.
Was this UI intended to be seen by the player? Yes. Yes. So the idea with this, like this slide out menu, the idea with it is that, say you are, because it's kind of a, I mean,
Thanks everyone for joining,
like a grinding game,
and supporting me.
So the idea
on the
is
journey
that it only popped out like a little bit,
failing design choices.
And you could see all your resources here to see how many you have.
Goodbye
so you can
everyone.
be like, oh, my next upgrade.
Goodbye YouTube.